One of the things that we can look at when we're talking about states of matter and change of state is we could look at a phase diagram, which up until now we've talked about how increasing or decreasing the temperature can change the state of matter, but we can also change the state of matter by changing the pressure. So if we look at this is a phase diagram. And so to the left, we're going to have the least amount of kinetic energy, least amount of temperature, and we have various amounts of pressure. So on the left, this is always going to be our solid. Okay. Clear over here to the right, we have the highest amount of kinetic energy, and we're leaving plasmas out of this, so this is going to be our gas. And then in the center where it looks like there's a funnel, this is going to be our liquid. So we can use a phase diagram to see at what temperature and what pressure it's required to get something to melt, to boil, to go through condensation, sublimation, deposition, and so on and so on. So let's just look at a normal situation. At 1 atm, normal atmospheric pressure. If I come over, according to this graph right about here, this substance is going to go from a solid to a liquid at 1 atm, which is melting. So if I come down, that tells me about 100 degrees Celsius, the substance will melt. If I continue moving over at 1 atm, the substance goes from a liquid to a gas, and vaporization, otherwise known as boiling in this case, we're coming down a little less than 400, so maybe 390 degrees Celsius is where the substance would go through vaporization or boil. Now, this is endothermic. We've been increasing energy. If we were over here at 600 degrees Celsius and I kept it at 1 atm and removed energy, slowed down till we got to 200 degrees Celsius, we would be going from gas to liquid, and that would be condensation. So at the same temperature that we said the substance would go through vaporization, that 390 is the same temperature that the substance will go through condensation. Same thing happens here at liquid to solid. If we're exothermically coming back, that 100 degrees that we said it was going to melt is also going to be the temperature that it's going to freeze. Now, one of the things that we could do is instead of changing temperature, we could actually change the pressure. So at 1.50 atms, I'm just going to put a dot right there. Best I can do with a dot with this thing. 1.5 atm, we're at a liquid. So if I'm to come straight down to about 0.50, that's not a straight line, I'm aware. If I come down at about 0.50 atm, notice I didn't change the temperature. I stayed at that 390-ish, 38-ish, but I did go from a liquid to a gas. So by decreasing the pressure, I was able to get the substance to go to a gas. Okay? So we go through that same boiling. So we did this in the lab when you boiled water at a lower temperature than normal. We pulled the plunger back on the syringe, which decreased the pressure, and we were able to boil. So notice when you have less pressure and get something to boil, it's going to boil at a lower temperature. All right, vice versa. If it takes more pressure, it's going to boil at a higher temp. Now let's talk about sublimation and deposition. This substance, if we came over at 0.5 atm, we notice that it will go from a solid to a gas or go through sublimation. And that's taken place a little less than 0 degrees Celsius, maybe negative 10. Okay, so at negative 10, the substance would go through sublimation. If we came back from 100 back, that's when we go through deposition. Now this point right here, this is called the triple point. This is the place where the solid, liquid, and gas can all exist at the exact same time, and this is what you guys did in your little dry ice lab. So the triple point of the substance is looking about probably 90 degrees Celsius and coming over about 0.65 atm is the triple point. And the triple point, once again, like I said, will tell us the perfect conditions of pressure and temperature to see all three states of matter at the exact same time, the solid, liquid, and gas. Here's a little background knowledge about phase diagrams. On QIA, you have the opportunity to go in and practice this, and I would do so to see how you're doing with change of states.